Hello, welcome. Today I'm going to talk about the 119 week contest. So this is my ranking, and I finished 4 questions. And for the first question, I spent about 3 minutes, and for the second question, I also got a bonus, and I spent about 10 plus 5, 15 minutes. And for the third question, I spent about 3 minutes. And yeah, for the last question, I spent about let me just count. I spent about nearly more than 15 minutes. So that's because I make a mistake. I got a typo and I didn't find it. It consumed me more than 20 minutes. So this is the ranking with with Chinese. Yeah, and this is the ranking globally. Yeah, you can tell the difference. So for ranking globally, I'm yeah nearly 1,200 out of 20,000. But while ranking in China, I got 400 out of 24,000. Yeah, you can see for here, I'm one of the 6 people inside of the contest. But while compare globally, I think if I calculated right, I should be one of 18 or one of the 19 contests. Yeah, normally the Chinese gonna be really good at data structures and algorithms, and yeah, maybe they are really good at the Leetcode problems. I mean, not the other platforms, but in Leetcode, they are really good at it. Yeah, now let me go to the 4 questions. Yeah, let me go to one by one. So this first one, let me translate it into English because while I did the test, I used the Chinese. Actually, there's no difference because sometimes English may be better and easy to understand than Chinese because sometimes they translated English wrong or sometimes they translated Chinese wrong. I don't know. Uh, yeah, so for the first question, we just need to return 2 numbers. Yeah, I nearly forgot what I did yesterday. Let me check. So yeah, we needed to return an integer array answer of size 2 containing the 2 values in the above order. So let's check the order. So the order is, for example, for the first array, this I is inside from the index 0 to index n minus 1, and this nums 1I occurs at least once in nums 2. So this means for this number, yeah, it should occur in nums 2. So it's gonna just check how many numbers occurred for nums 1 in nums 2 and how many numbers in nums 2 occurred in nums 1. So it's gonna be an easy problem if you understand the question properly. So for example, for this number 4, it didn't appear in nums 2. What about 3? It appeared. What about 2? It also appeared. What about 3? It appeared. What about 1? It didn't appear. So we're gonna return a 3 for the first value. And for the second value, we're gonna check nums 2. So for the first number 2 appeared, second number 2 it appeared, and then we're gonna count 5 not appeared, and this 2 also appeared. Yeah, and this 3 also appeared. So there are 4 numbers, 2, 2, 2, 3, and this 6 is not appeared. So yeah, it's gonna return a 3 and 4. Yeah, so as you can see, it should be an easy problem. And for this one, there's no numbers in nums 1 appear in nums 2, so it's gonna be 0. And for nums 2, there's no number in nums 2 appear in nums 1, so it's gonna return a 0 and a 0. So I did it exactly like that because normally for the Leetcode easy problem, so this is the easy problem. This m at n gonna be really small, so I can use the brute force to solve it. So even I here use the inside, yeah, for n1 inside n2, it consumes on time complexity. So here is on. Yeah, let's just check for the nums 1 and the nums 2. The length will still be n for me to analyze the time complexity. So this is on. and this is just OM. Yeah, let's just say it as ON because it's nearly the same because it is bounded from 1 to 100. Yeah, so actually it is 10,000. It is N square. For ON square, but it's 10,000, normally it can pass. And because this is just the easy problem, we can always use the brute force to solve the problem. It can save a lot of time. We don't need to think about it. Just yeah, write according to the description and get the result. Uh, yeah, let me just submit again, just to prove it should yeah it should works. Now let me go to the second question. The second question is gonna be a little bit harder, but for me, I think the second question would be harder than the third question. Maybe it's similar to the fourth question because the fourth question is basically a template. If you know how to calculate the shortest path, and if you know about disastrous algorithm or Floyd algorithm, normally you can solve it. Yeah, at first I'm thinking about the disastrous, but I think it's gonna not be possible because yeah, a lot of the time it will consume a lot of time. So I changed it to Floyd to solve this problem. Now let's just go to the second problem first. Yeah, I think I can still see my record while I'm doing the contest. Yeah, let me check. So this is what I did. I did a mistake, and this mistake is I didn't take care of the stack properly. I used the stack. Normally, I believe if I don't use the stack, I can still solve it. Maybe I can avoid making the mistake. But yeah, because for me, while I'm using the stack for the else part, I didn't consider it gonna be. Yeah, I didn't just prepare the stack to be an empty array and put the word I inside. So let me just copy the code. Yeah, because for here, actually, I corrected just use yeah several seconds. Yeah, so for this second question, we are just giving a word. So inside the word, it's gonna be any lowercase English letters, and we need to return the minimum number of operations needed to remove all adjacent almost equal. So what is almost equal? So that is if A equal to B or if A is adjacent to B. So for example, AA, they are always equal. We need to find a way to remove. For example, uh, we can replace this A with another letter, maybe C or D. It doesn't matter. Only meet the conditions of the minimum operations. Yeah, and we can also change this A to another letter, maybe just C. Yeah. So how many changes? There's only two changes. Yeah, you can also consider this way. You can just, I think you can just split the array into several parts and check how many uh, how many letters, how many characters in between you need to remove. Yeah, but this gonna be really hard to code. It's easy to code, but it's also easy to make mistakes. You have to, yeah, basically you have to use the index to check all the possible results. Another way I think it's gonna be easy to use a stack. While using a stack, it's gonna be, I think, at least easy to understand. If the word is just empty, we just need to return 0. We don't need to do anything. Yeah, because there's nothing inside. But the word is not empty. it gonna at least have one word. Yeah. So basically, I don't even need to use this lines of code. Now I just need to prepare a result. This result is to check how many letters I need to remove. But while the stack works, because if you put the letters inside, so for example, if you put an A inside, you put another A, what's gonna happen? You need at least one operation. So this is the greedy idea, because this is not possible. So if it is not possible, what are you gonna do? You just need to pop it out. So for the first A, you put it in, you prepare an empty array and put it inside a stack. So you prepare an empty stack and put it inside. Currently inside of the stack there is an A. Now for the next A, you're gonna check. It didn't meet the condition because A equals to A. Yeah. So here is A equal to A, or A is next to A. So yeah, I'm gonna use the absolute of odd of word I minus odd stack minus 1. So this means this A with this A. Yeah, if it didn't meet the condition, I'm gonna pop out this A from the stack. And for this A, I didn't do anything. This means those two A's already be consumed. And I get a record of one time. So result would plus 1. Now for the next one, for this A, I'm gonna still put an empty stack and put it inside an empty stack. Yeah, I think there may be some easy ways to solve it. Yeah, but for me, I think a stack is easy to understand. And for this A and this A, I still use one operation. I still pop it out. Currently, the stack is empty, but I used two operations. Now, while it comes to the third operation, there's just a A, because the stack is empty. So what I'm gonna do? I prepare an empty stack and put this A inside of the stack. So this is the end of the loop. I just need to return the result. It is a 2. Yeah. So basically, it is like that. Yeah. So let's check another example, maybe easy to understand. Yeah, it's gonna be the same. So for example, this is Z and Y for this example. Yeah, because it is a neighbor, absolute equals to 1. So those Z and Y would be consumed. What's gonna be next? Next, I'm gonna have X and Y. So for X, Y, it is also neighbor. So this X and Y will also be consumed. And next, this X and Y will also be consumed. And for the last one, it is just a Z. So this Z didn't count. So it is just 3 times. Yeah, I'm not sure. I think this idea is still difficult to think about it, because while it comes to the greedy idea, it's difficult to think. And for this example, this is AB. It consumes 1 time. Because for this AB, you need to consume at least 1 time to solve it. You have to replace this B to another letter. Yeah, maybe you think, why not I just replace this A to another letter? But the greedy idea is to replace this B to another letter. Maybe it will influence this B. If you replace this B to another letter, maybe this B and D is still okay. So this is why we're gonna always choose the second letter. Yeah, so for this AB, it consumed once. And now it comes across with DD. DD will also be consumed. Yeah, and now it comes to E and Z. So for E and Z, it didn't do anything because they are not neighbors. But what I'm gonna do, I just put the E inside an empty stack. So inside of the stack, it is just E. But while it comes to Z, so this E will be what? This E will be just pop out because I prepare an empty stack. You can say that is the empty stack. Now I put this Z inside of the empty stack. Because this E doesn't matter, I will only consider this Z. Yeah, because E already meets the conditions, I will not count it. So I prepare an empty stack and put it inside a Z. So for the next letter, it may be, for example, it may be a D. D and Z, it is okay. But if I didn't prepare an empty stack, so if I pop out this Z, this is E, another one may be D, E and D will count another time, but that will be a mistake. So I have to prepare an empty stack. Yeah, I think there are better ways to solve this problem. Maybe not even need to use use this stack to solve it. Or let me put it easily. Or maybe I don't need to prepare an empty stack. I just make a stack equal to the word inside. Yeah, just make it like this. Let me check if it works. Yeah, it seems to work. Now let me submit it. I can save some slice of code, but the idea is just a greedy idea. But we can use a stack data structure to solve this kind of a problem. Because for stack, it is just O(n) time. And this n gonna be a very small value. Yeah, it didn't said how much percent. Let me try to submit it again to check what is the percentage. There's no percentages, maybe. Yeah, there's no percentage. It just told the memory it is 100, but it didn't tell me about the time. Maybe there's not so much data. Use Python. Yeah, but it is okay. Now let me go back to the third problem. Yeah, I think I can click there too. Yeah, but let's just go back. So for the third problem, yeah, we are going to calculate the length of longest subarray with at most k frequency. This is a typical sliding window problem, and it's really easy to understand, and it's really easy to code. Normally, you will not make any kind of mistakes because this is basically a very, a template problem. You just need to use a sliding window, and for the sliding window, you need to return the length of the longest good subarray of nums. Now let's check what is the good subarray. So the frequency of an element x is the number of times it occurs in the array. Yeah, an array is called good if the frequency of each element in this array is less than or equal to k. Yes, now let's check an example. So the longest possible, maybe this one. 1, 2, 3, 1, 2, 3. Yeah, because k is 2. If it goes to this one, so the count of 1, frequency of 1 will be 3. It will be more than 2. Yeah, as you can see that we can just use a sliding window to check the longest windows. So the condition is the frequency of each numbers inside the window can not be more than k. If it is more than k, we will do something. If it is less than and equal to k, we're gonna record our result. Yeah. Basically, for this question, I spent about 3 minutes. Yeah, because it's a very basic template, and you can see from here. This is while I'm doing it just one time, and I prepare to use this example and to finish it here. Yeah, let me explain a little bit about the coding part. Yeah, because even this, I needed to spend about 1 minute to understand the question, and then I'm gonna use 2 minutes to finish the coding. And I need to prepare a default dict, and I also need to prepare the result and the left index. Then I'm gonna enumerate from the right index, and this is just the number. And for the dictionary, I need to record how many numbers inside the dictionary. If it is more than k, I'm gonna do something. Yeah, but before shift the window, I need to check the dictionary. So the nums L at the left side should -1. Yeah, while it goes out of the while loop, I'm sure it's gonna meet the conditions. I just needed to have a record of the result. So it's gonna return the result. Yeah, so normally this question should be a second question. But for this contest, the second question is really hard. I think the second question maybe put it to the third place. So this one may be similar like a second question. As you can see, it is not so difficult. Yeah, just a very basic sliding window. Now let me go back to the fourth question, because which one is the fourth question? Number of possible sets of closing brackets. Yeah, I think this one gonna be the fourth question. Let me go back to this one. Yeah, let me copy what I did during the contest, because this one gonna be a little bit harder. I didn't optimize. I didn't optimize my solution, because while I'm checking the. Oh, this is what I did. I don't believe it. Yeah, I read so many lines of code. I didn't believe it. Yeah, but actually, this is what I did. It's a totally brute force. Why I use a brute force to solve it? Let me copy the code. Yeah, it is a lot of lines of code while I'm writing this check function. This check function is basically the Floyd. Yeah, it's a totally brute force. Yeah, because what? Yeah, for this question, normally I don't believe I can solve it, but while go down to check the constraints, it told me this n is just 10. Maybe if it is a 10, it is a 20 or 100, I believe I can never solve such kind of a problem. Because this n is just so small, I believe it's possible to solve it by brute force. So what is brute force is just to enumerate all the possible results. For here, I just save a little bit of time, because I believe this 1 plus n. So this 1 plus n means if I I almost forgot. Yeah, this is not so easy to say what's inside. Yeah, so normally during the contest, the background is white. You're gonna see it clearly what it is. Yeah, so for this question, we're gonna find a way to remove a node. If it meets the conditions, we're gonna count it as 1. If we didn't remove anything, we're gonna still count it as 1. So for me, I prepare a 1 plus n. This means I remove all the nodes. So there's one way. If I remove all the nodes, it must meet the conditions. Yeah, because here I believe there's some examples that the set 2, the set. Yeah, let me find a better example. Yeah, let's check this example, maybe easy to understand. Example 2, and the set is empty after closing. Active branches are 0, 1, 2, and they are reachable to each other. So for 0, 1, 2, they are reachable for each other. So for me, I just enumerate all the possible cases, and I would have a check. If it can meet the condition, I'm gonna have my result plus 1. Yeah, and so for this one, it means if I remove all the node, it must meet the conditions. Yeah, because there's no even node inside. Yeah, if I remove all the node. For this n, if I remove n minus 1 node, it means I just left 1 node. So for example, there are 3 nodes, 0, 1, 2. I just left a 0 or 1 or 2. So how many ways? So there are n ways. Yeah. Now I'm going to try to what's left behind. Left 2 to n. Yeah, so this is I left 2 node, and then I left until to n node. And how many possible ways I gonna use for say inside the combinations of this array with I. So the I will become from 2 to n. Yeah, if I keep 2 node, what gonna happen? So for example, 0 and 1, 0 and 2, or 1 and 2, I gonna check if it is possible. So basically here inside it is just prepared for the Floyd algorithm. I'm gonna prepare a graph, and this graph is basically a matrix, and every value inside is just infinite. And for this UVW, that is just the that is I almost forget what is normally for this UV is node for U node to V node with a cost of 20. Yeah, I put it inside uh, the graph. So this graph is just a matrix. I put it inside the matrix, but I need to have a tag. If this U inside the nums, because here this tag is just inside the nums, I gonna put some values inside. Yeah, let me see tag. So this C is just a combination. So here I put it as the nums if one of the combinations. So if this node U and V is inside the nums, yeah, normally I can optimize a little bit, use a set, because if I use a set, it is just 01. But for this nums, for the maximum, it is 10. So I believe even I don't optimize, it should work. So I gonna put it like this. Yeah. So here I prepared the matrix. Yeah, and basically this part is for the preparation of the Floyd algorithm. Yeah, as you can see, and here there's also a little bit of trick. I prepare a minimum of the weight with the W, because sometimes for example this one 0 1 20 0 1 10, I should always choose the minimum. Maybe I would need to have a 10 because 0 to 1 there's 20 and 10, so I choose a minimum. Now here comes with the Floyd algorithm. Normally I would prepare 3 loops, so for this M, I, and Z, and then for this G with I to Z, I need to check the minimum I to M and M to J. And this M is just the outer side loop, the first loop, the outer side loop. And this is like a brace for I to Z. If I were to go from I to Z, I need to I to M and M to Z, and I would check the minimum. And now I finished the Floyd algorithm. I've already got the minimum result inside a matrix. Yeah, inside the matrix G. And the last step is I just need to check inside the matrix if this R and C inside the nums. So I'm sure this R and C can combine to add, and also the cost of R and C is more than the max distance. So I'm sure it's gonna be a false, because there's still one edge more than the maximum. For example, this is 5. It's gonna be a false. Otherwise, if I didn't find it, I'm gonna return a true. Yeah. So as you can see, it basically this is just the brute force, and it's not difficult to think about it. But maybe for the coding, yeah, sometimes you would make a mistake or 2 mistakes, but you can easily to fix it. For me, I remembered I make a mistake. I forget where it is, but yeah, I make a mistake at this areas, because at this areas I checked too early for the G with the I and G. I didn't find it clearly, and then I put it outside of the for loop. I gonna check finally from here, and it works. So yeah, I just used one time it passed. Yeah, so this is the 4 questions from the Leetcode Week contest 119. If you think this is helpful, please like and subscribe.